but it's not, once you get the hang of it, it might come easily to you. And then you'll be, I hope you feel very proud at the end of this because you'll know what to do with what are called imaginary numbers, which sound like a high-level math thing, right? Because you're doing high-level math. So when we write a negative number under the radical, if the root or the index, this number here is let's do 8. If this is a 3, that's okay. The third root of -8 is just -2, right? Because -2 times itself, sorry, can't see that last negative. -2 times itself 3 times is just -8. It is possible to get 3 negative numbers to multiply together to get a negative result, right? However, if we take that same -8, is it -8? No, we'd have to do -4, so it didn't matter. I don't know why I thought 8 was a perfect square. It clearly isn't. I just wanted there to be something that was a perfect cube and a perfect square, not the number 8. So let's look at -16 as we were looking at before. If this is a 3, it's going to be some number, right? Some decimal. The third root of -16 is possible, right? It's a -2.5198. However, the square root of -16 is never going to be possible. And what they call it, sorry, that's not English, but what they call it is an unreal answer. So response is answer. So it's a not unreal answer. Unreal, imaginary. Okay. So when you say there's no solution because the answer is not real, today we're going to find the solution using an imaginary number. Okay. So -16 is not real because there are no 2 numbers that you can multiply. You can't multiply -4 times -4 to get -16, right? That is not true. So that's why it's not real. The even roots means we are using 2, 4, 6, right? So any even root, you can't take the negative of it because no even, like when you multiply 2 numbers, 2 negative numbers, it becomes positive, right? So if it's in groups of 2, it's always going to end up as a positive number, so it's not real. If they're in groups of 3, it'll work because a negative times a negative is a positive, but then a positive times a negative is a negative again. So that's why it's only the even roots that become imaginary numbers. So previously, when we encountered square roots of negative numbers in solving equations, we would say no real solution or not a real number. It's still true, but now we can introduce an answer using imaginary numbers. Imaginary numbers include 2i, -9i, 33i. So the imaginary unit I is being multiplied by whatever your number is, making that number imaginary. Good. We need an imaginary number when the calculator tells us that our answer is not a real number. Okay. What you need to know about the imaginary unit, all there is to know about the imaginary unit is that the square root of -1 is equal to I. Okay. The square root of -1 is equal to I. So anytime you have the square root of -1 or the square, or sorry, anytime you have a -1 under the square root, it becomes I. Good. If we know that I is the square root of -1, what if I wanted to find I squared, right? To undo the square root, we square it, right? So if I square I, my answer is I squared. And if I square the square root of -1, that square cancels out the square root, or the square root cancels out the square. They're opposites, right? So I squared is -1. That's all you need to know about the imaginary unit. Okay, so that means anytime you see the square root of -1, you want to write in I. Okay, we're replacing the square root of -1 with the letter I. And it does, in many ways for this class, as far as we are concerned, act like a variable. Okay, so when you have a -1 under the radical, replace it with I, no radical, it's over. Your radical is gone. You have an I at the end of your number. 2I, -9I, 33I. I guess I can go on right here. This is a lot of space. So if the square root of -1 just becomes I, then the square root of -5 becomes, just like we do factor trees, the factor tree for a negative number will include -1 times the positive of that number, right? -5 is the same as, well, we should quit that. -1 is the same as -5 is the same as -1 times 5, right? So that's just a factored form of -5. I know that if I see this, I can write this, and I see that, okay? So the square root of -5 is I outside the radical, right? No radical. I square root of 5. So we got rid of the negative. It's now an imaginary number, but we don't have to stop, right? We got to take it an extra step further. Usually we would say the square root of -5 is not a real number, and we would stop. Instead of saying it's not a real number, we're going to say it is an imaginary number, I square root of 5. That's all we're doing today, okay? Or that's the main concept of what we're doing today. I shouldn't get your hopes up, right? You have a lot of other classes you would like to keep it simple. I will try to keep it simple. So if it is a perfect square that you're taking that you've made negative and you're taking the square root of, right? That means just like -5 became -1 times +5, -9 can be -1 times +9. We know that the -1 under the square root becomes I, square root of 9. Now that 9's a positive, and we know what the square root of 9 is, right? The square root of 9 is 3, because 3 times 3 is 9. So we have sorry, I couldn't decide which order to write it in. So I square root 9 becomes I3. The reason I hesitated there is because you should always put the I behind. So I was like, do we skip that step or explain that step? That this becomes 3, this is I, so it's 3I. Always put the number in front of the I. Okay? Okay. So let's write the square root of -25 using I notation. Remember, what we need to know about I notation is that I is equal to the square root of -1. So the square root of -25 is the square root of -1 times +25, because I know 25 is a perfect square, right? 25 is 5 times 5. So that becomes I. That one becomes I. +25. We know this because we've been practicing it a bit. So it's just I times 5. I'm going to rewrite it as 5I. Five times the square root of -121. So if I just look at -121, -25, 25 was a perfect square. Is 121 a perfect square? It is. 121 happens to be 11 times 11. So 5 on the outside square root of, just like up here, separate out -1 times positive 121. Good. 5 is still on the outside. I think you're going to know what to do, right? The square root of -1 becomes I. Now that's a positive 121. We saw that positive 121 is 11, right? So now we have 5 times I times 11, just like when we started radicals at the beginning of this unit, when you take something out of the radical, you just multiply it by whatever was in front, okay? Whether that be 5, whether that be a negative sign, whether that be a 5x, some kind of variable, just multiply them all together. We should get 55I. Final answer. Good. Here's another just quick practice. Same number, right? But instead of a 5, we have a negative. So here is the square root of -121. We know that -121 becomes 11I, right? Because it's -1 times a positive 121. The positive 121 becomes an 11. The -1 becomes an I. There's nothing left under the radical, but there is this negative. So we carry that negative over. In the past, or outside of imaginary number world, a negative followed by a negative would just make the whole thing positive and both of those would cancel, right? But if you have a negative under the radical, I want you to change it to I before you combine it with anything, okay? Don't combine it with anything, change it to I before you combine, okay? So that becomes the I. So all we're combining with the negative is the 11I. No, negative 11, okay? Take it out as I, then combine it with other things. We'll see it again. -32. This one is a bit more straightforward. So just like -25 was I5, 32. All right, we'll start with square root of -32. It's going to become -1 times positive 32, right? -1, as we're making our factor tree, just becomes I outside the radical, okay? No more radical there. We have 32. What does 32 become? Whatever you want. At this point, if you feel comfortable, I would recommend you just going through the perfect squares that you know. So 32, what perfect square is below 32? 32 divided by 5 times 5, right? 32 divided by 16. Oh, that's nice. So 32 is the square root of 16 times 2. Good. 16 is the perfect square of, the perfect square of 4 times 4, right? So 16 also comes out as 4. So now we have 4I square root 2. So once you carefully take care of the I, it's just like the other radical work we have done in this class. Okay. Same here. We're going to take the -24, get it as far as we can, leave it as sort of a mixed term with whole numbers and radicals, and an I. Ooh. I think when making the video, I made it wrong. All right, anyway, I'll get it right for you guys. So we have a 2 outside. We'll just keep that so that I don't make a mistake like I made it last time. We have a square root, -24, we're going to call -1 times positive 24, right? Now we have that 2, that -1 becomes I, the square root becomes 24. 24 is anything? 24 divided by, can't be 25, 16? No. 24 divided by 9? No. 24 divided by 4? Yay. So 24, that's now positive because the negative becomes the I. 24 is now 4 times 6. 4 is a perfect square of 2, right? So then we take out the 2, and we're left with a 6. Good. There's the original 2. So we have the original 2. Then we have an I. And we have another 2. Square root 6. Okay. Just like we multiplied the 11 times the 5 and got 55, here we're going to multiply the 2 by the 2 and get 4i square root 6, because I think 6, I don't think that there's any perfect square you can take out. Good. 4i6. Now, that is how to change a negative radical to an imaginary number. Okay, these are all imaginary numbers. 5i is imaginary because of the I. 55i is imaginary because of the I. It doesn't matter if it's negative or positive. It's imaginary because of the I. Good. Multiplying, dividing, and simplifying with I. Okay, like I said with the 11, make sure you change it to I before you combine it with anything. Even if you know that if these were positive, you could call 3 times 5 the square root of 15, right? We know that the square root of 3 times the square root of 5 is the square root of 15, right? It's not true for negatives. So for negatives, you want to take each piece and call it -1 times itself. Or times the positive version of it, sorry. You want to take the I out first. So -3 becomes 3 times -1. -5 becomes 5 times +5 times -1. So that is I square root 3 times I square root 5. Okay? This is true. This is true. Now, combine the terms outside the radical, you get I squared. Combine the terms inside the radical, you get 3 times 5. So we have I squared square root of 15. Good. One more step, because we know that the square root of -1 is I, but we know that I squared is -1. So if you ever see I squared, you're ready to replace I squared with a -1. Okay. So that I squared square root +15 is going to become negative square root of 15. Here we have the square root of -125 over the square root of 5. The square root of -125 is going to be the square root of -1 times 125, right? Over the square root of 5. I want you to change that first, okay? So that now becomes I square root 125 over square root of 5. Now that you do not have any negatives, you only have a positive and a positive, now we can change it to one radical. We can leave I out in front. If it's on the top, that's the same as having it in the middle, right? So I times 120, the square root of 125 over 5. Then I recommend, if this is a perfect square, you can take the perfect square. 125 isn't a perfect square. 5 isn't a perfect square. So instead, you can divide them. 125 divided by 5 is 25. So we have I square root 25, which is 5i. Square root of -96 over the square root of 3, same thing. So we know this is going to be I square root 96, right? I'm just going to skip that step because that just becomes that, right? I square root positive 3. Now, when we factor, we have factored out the I. The I is a common factor to both the top and the bottom. So we can cancel it. We couldn't cancel it here because it was only on 1. So we put it out in front. But here we can cancel it completely. And now you get the square root of 96 over the square root of 3, or the square root of 96 over, 3. Put it in your calculator. If these were both perfect squares, you could take them. That might be easier. But if not, try dividing it and see if you get a nice friendly number. 96 divided by 3 is 32. So we have the square root of 32. Might not be done yet. Take 32. Find out if there are any perfect squares in it, right? Sorry if we're repeating with the same numbers. 32 divided by 32 divided by what? 25. 32 divided by 16. So that becomes 4 square root of 2. So all of that in the end is equal to 4 square root 2. Oh, let's see if it's true on the calculator. So the square root of negative 96 divided by the square root of negative 3. Oh, they're not letting me. Good. All right, so just a few more examples. This is the most difficult part. After this, it gets easier. All right, so this is the same thing we were doing up here, just 4 more examples. Square root of negative 5 times the square root of negative 6 becomes I square root 5 times I square root 6, right? I times I becomes I squared. Square root of 5 times the square root of 6 becomes the square root of 30. 30, I don't think we can divide it by 4. We can't divide it by 9. We can't divide it by 16 or 25. So I think there's no way to simplify that, but there is a way to simplify I squared, right? Because I squared is negative 1. So we're going to call that negative 1 times the square root of 30. So just negative square root of 30. Same here, let's skip to the square root of negative 9 becomes I square root positive 9 times, the square root of negative 1 is just I. The square root of 9 is 3, so this is 3I times I, so that's just 3I squared. 3 times I squared becomes a negative 1. 3 times negative 1 is negative 3. Here we have the square root of 125 times negative 5. Or sorry, the square root of negative 5. So let's think about how we can factor 125. If we think about how to factor it with a factor tree, 125 can become 5 times 25. Good. You've actually, you don't have to do it this way. You can factor out, you can simplify the 125 first, or you can multiply the 125 by the 5 once you take out the I. Either way, okay? So the square root of 25 is 5. So the square root of 125 is just 5 square root of 5. And then over here, we have I square root of 5. Right? 5 times I is 5I. But under here, we've got 5 times 5 again. So this is 5I times, that'll be 25, right? But 25 comes out, so it's 5I times 5. So in the end, we have 25I. So you can factor out the 5 and the 25, factor out a 5, or you can say that this is the square root of 125 times I square root of 5, 125 times 5. Looks like that. And then I'm going to take the square root of that, and I'm going to get 25. So you're welcome to do it that way as well. So that becomes the square I square root 625, which is I times 25, which is the same answer. Here we've got I square root 27 over square root of 3. Once you remove the I, put it out in front, 27 over 3. Good. If I take 27 and I divide it by 3, I get 9. The square root of 9 is 3, so this is 3I. All right, we have 20 minutes. We're not going to do any more with, there'll be like one example problem with radicals. But what we're going to do now is talk about imaginary numbers. Imaginary numbers have I. If a number has no I, it's a real number. So for example, 8 minus 3I, the negative 3I is imaginary, the 8 is real. Okay. When you have one term or one quantity that includes both imaginary numbers and real numbers, we call it a complex number. Complex, like complicated, right? Or more than one thing. So you have an imaginary side and you have a real side of your complex number. So now we're going to talk about complex numbers. We're going to add and subtract them, which is just like combining like terms. Then we are going to multiply them. A complex number, it looks like this, okay? It's not one number. A complex number will always have a plus or a minus. A complex number is a number that can be written in the form a plus bi, where a and b are real numbers. A is the real part, b is the imaginary part because of the I that is attached to the b. When b is 0, right, that would make this a plus 0I, which is a, which is real. Right? So if b is 0, it's a real number. If a is 0, that means, different color. If a is 0, that means 0 plus bi equals bi. Because of that I, it's imaginary. If it only has one term, it's either imaginary or it's real. If it has two terms, it's complex. Sum or difference of complex numbers, you can look at this, but it's just combining like terms. It's exactly the same as when we were combining like terms. The definition for the sum or the difference is if you have A plus BI, and another example that's C plus DI, their sum is you combine the real, I think we made real yellow. You combine the real and you combine the imaginary part. And you make sure you put an I with the imaginary part. Okay, so A plus BI plus C plus DI means A plus C becomes your first term, B plus D becomes your second term with an I behind it. The difference means we're subtracting, right? So in subtracting, just like when you're combining like terms, you're distributing that negative. So we have an A minus C, A minus C, A minus C for our real. Positive BI, but that negative is going to get distributed to the BI. So it's BI minus DI, and that's your imaginary part. Okay, so if you like it that way, excellent. Or just distribute this minus and then combine like terms as though the I is any other variable. 8 minus 3i minus negative 6 plus 2i. So I'm just going to write 8 minus 3i. Distribute the negative. Minus a negative 6 is a positive 6. Minus a positive 2i is just a negative 2i. 8 plus 6 is what, 14? Negative 3i minus 2i is negative 5i. So I'm just combining the two imaginary that were both negative and the two real into 14 minus 5i. Same here. 6 plus 4i minus negative 7 plus 5i. 6 plus 4i minus a negative becomes plus 7 minus a positive minus 5i. So we have our real number 6 added to the real number 7, and we get, can you see it? No, I should write it here. 6 and 7 is 13, right? And then you have a 4i minus 5i. So we're going to subtract 5 from 4 and get negative 1i, but we can just write negative I. Okay, so just like combining like terms. You might see something where you have a real number and then we're subtracting an imaginary number from, or sorry, we're subtracting a complex number from a real number. And what would happen there is same thing. So we still have the 6 minus a positive 8 becomes negative 8, minus a positive 4 means minus 4i. Good. So 6 minus 8 is just negative 2. And then that's the only imaginary part. So we're just going to write negative 4i. Here was the real part. Here's the imaginary part. If you have a plus sign, you don't need to do anything. You can just start combining like terms. 4 minus 7i plus 2 plus 3i. 4 plus 2 is 6. Negative 7 plus 3 is negative 4i. Right? Because 3 minus 7 is negative 4, or 7 minus 3 is 4, but the 7 is a negative, so the 4 is going to be a negative. Here we have a complex number and we're just subtracting an imaginary number. That's fine. 8 plus 2i minus 4i. 8 remains the same. A 2 minus a 4 is a negative 2i, right? Now, last concept for this lecture is multiplying complex numbers. To multiply two complex numbers of the form a plus bi, you saw how they interacted with each other up there with the adding and subtracting, right? You just group like terms. So for multiplying, we're going to multiply as though they were binomials and then replace I squared with -1, just like we did when we were transitioning from negatives under the radical to I form. Good. So we're going to multiply the 8 in front of the I with the 7 in front of the I, and then we're going to multiply the I times the I, just like any other variable, okay? So this becomes -8 times -7. That's how you write sevens. This is -8 times -7 times I times I. Good? Just like if they were x's. So -8 times a -7 is a positive 56. I know I didn't put the negatives in. Positive 56. I times I just means there's two of them, so they're squared. However, if I see an I squared, I want to replace it with a -1. So that's now 56 times -1, which is a -56. Good. All right. Here, that was just a monomial times a monomial, right? Multiply the numbers, multiply the variables. Here we have a 5i times a 4, and then we have a 5i times a -7i. So you're just going to distribute the 5i. 5 times 4 is 20, right? Let me know when I make a mistake. There's no other I to multiply, so we're just going to say it's 20i. Now, 5i times a -7i is going to look like -8i minus 7i, right? 5 times a -7. I guess I don't know what sign to put there yet, right? 5 times -7 is a -35. So it's 20i minus 35. And then we have an I squared, right? The 5 times the -7 became the -35. That I and that I multiply together. So I will rewrite it as 20i minus 35i squared. 20i minus 35. Let's switch the I squared with a -1. So we're taking -35 times -1. Okay, just put it in your calculator. -35 times a -1 becomes a positive 35. So I have 20i plus 35. Don't put this in as your final answer. We always want to put it in a plus bi form. I should have actually written that, typed that into the notes, but I didn't. So put it into a plus bi form. So make it, instead of 20i plus 35, make it 35 plus 20. So here we're just multiplying one term by one term. Here it was one term by two terms. Now we're going to move on to fully foiling. And you're doing the same thing as when you foil. Just after you're done foiling, make sure you take I squared and change it to a -1. Okay? So 6 times -7 is what? -42. Good. 6 times 4i is, don't be shy with your calculator, 24i. Good. If your calculator makes your life easier, use it. Don't add, right? Don't add stress if math stresses you out. -3i times -7 21i. And then we've got negative 3i times 4i, right? Negative 3 times positive 4 is a negative 12. And we know that I times I is going to be called I squared. Now, I'm probably going to write it up here because I'm out of space. So all of that becomes negative 42 plus 24i plus 21i first, outside, inside. Yeah, okay. Was expecting more negatives. Minus 12i squared. Good. Let's combine these two. When we combine 24 and 21, 20 plus 20 is 40, right? 4 plus 1 is 5. 45i. It's a positive. Keep the negative 42. And we have a negative 12. Let's take that I squared and change it to negative 1. Now I have negative 42 plus 45i plus 12, because a negative 12 times a negative 1 is a positive 12. So now what I'm going to do is I'm going to combine. I have new, all of a sudden, I have new like terms, negative 42 and positive 12, because instead of an I squared, it's now just a real number. Negative 42 plus 12. Negative 30. So my final answer is negative 30 because I need the A in front plus 45i. Sorry, I got a bit crowded. And I'm definitely taking all our time. Okay, we got 2 more. Ah, we have 3 more. The square root of 5 minus 2i times the square root of 5 plus 3i. This one's important. You'll have one of these on my math lab, okay? FOIL it just the same. So the square root of 5 times 5, right? Then we have square root of 5 times 3i. Then we have, I'm sorry, plus, minus 2i square root of 5. And then we have negative 6i squared. Good. So first was just a square root times a square root. Next was an imaginary number times a square root. Then we had another imaginary number times a square root. I'm putting the square roots in the back because that's always where they are. Don't worry about if it's negative square root of 5 times 3i. Put the 3 up front so you don't get confused, is what I would recommend. And then negative 2 times 3 is 6. I times I is I squared. We know that the square root of 5 times 5 is going to be 5, right? Because that's 25. Plus 3i square root of 5 minus 2i square root of 5 minus 6i squared. What do we do with an I squared? We call it a negative 1. Okay. So now I have 5. Look at this. It looks scary, but I have a number times I squared root of 5 minus another number times I squared root of 5. So what I need to do here, the only thing I need to do here is take plus 3 minus 2. I square root of 5. Okay, so you're not doing anything with the I square root of 5. We're just combining the 3 and the negative 2. Plus 6, right? Because a -6 times a -1 is a +6. So now let's combine 5 and 6 become 11, right? 3 minus 2 is 1. I square root of 5. Good. This one, you know, there's no new concept here. It's just if you see this, make sure you write it as -7 plus 6i times -7 plus 6i. And then FOIL it out, just like we foiled this one. Good. All right, and then these are called reciprocal. No, they're called the complement, because you have the same 4 and 3i, but one's being added and one's being subtracted. And what's going to happen is you're going to get 4 times 4 is 16. 4 times -3i is -12i. 3 times 4 is a +12i. And then minus 9i squared. We have 16. Those cancel because it's a -12i and a +12i. And we just have minus 9i squared becomes a -1. 16 plus 9 is 25. If on Wednesday you want to see more examples of this, just let me know and we'll do a few more examples of that. But that is all you need to know about complex numbers. Thank you guys so much. You are obviously welcome to go, and see you Wednesday. Oh, thank you too.